Hi everybody, I am Miss Lindsay and this is my science school. Today we're going to talk about something that is very important to forecasting the weather, and it's very important to your day-to-day life as well. We're talking about temperature. Temperature is how hot or how cold it is outside. So when you walk out the door in the morning, you might first notice whether it's raining or snowing like it was for many of us this morning, or you might notice that it's sunny. And I bet the second thing that you notice is how hot or how cold it is. So man, when it's hot out there in the summertime, oh, you start sweating. Wow, it's so hot. You start complaining to your mom. I know you do. You want to know how I know? Because I've got kids and they complain when it's so hot. And then you know what? They complain when it's so cold as well. Oh, Mom, it's so cold out here. Do you do that? I bet you do that. Okay, the way that we measure how hot or how cold it is with a device called a thermometer. A thermometer has what's called mercury inside it. That's that red stuff inside the thermometer that goes up and down the tube. And when it's really hot outside, like 90 degrees, that's how hot it gets in the summertime, that mercury goes all the way up the tube. When it's really cold, like it is around Christmas time, you'll notice that the mercury is very low in the tube, maybe 30 degrees or so. It's very, very low. Why does the mercury go up and down the tube of the thermometer based off of how hot or how cold it is outside? Well, it all has to do with the molecules inside the mercury. And this is the same thing that happens with a lot of different elements we have out there. When that element is cold, like the mercury in our thermometer, those molecules are moving slowly and they're really packed in tight together. This thing gets compressed, it gets smaller. But when you warm that mercury up, those molecules inside the mercury start moving faster. They start running like crazy, and that allows it to expand. So that's why the mercury goes up the tube in your thermometer when it's hot, and it goes down when it's cold outside. Let's go over to my science desk now. I want to introduce you to my friend, Miss Jade. Jade is going to help us with our science experiment for the day. Jade, say hello to all the kiddies.
Hi, friends.
We're going to have fun today. We're going to make our own thermometer and show you how you can do yours at home. Couple of things that we're going to need for this. We're going to need a 2-liter bottle that's got the soda taken out of it. Okay, so you'll have to put the soda into something else or have already had that to drink for dinner last night. Then we're going to need that index card that you've got right there. So maybe you've used these to take notes for school or for projects. You'll need one of those. You'll also need a marker of some sort right there. And then you're going to need a straw. Got the straw. Thank you for modeling, Miss Jade. You're such an excellent science model.
But there's a reminder about the straw.
It has to be clear so you can see what's going on in the tube, because this is going to be our tube for our thermometer. So as I found out yesterday, clear straws can be very hard to find. So maybe the next time you're grabbing some takeout dinner,
yes,
you can ask them for some extra straws, and then you can make this at home. Okay, a couple of other things that we need. You need some modeling clay or some Play-Doh. We're just using Play-Doh today. Just a small thing of Play-Doh. You don't need very much. Then we're also going to need some tape and some red food coloring as well. So that's what we need to do today's experiment. The first thing that you're going to do to build your own thermometer at home is you're going to pour some water into your bottle. Now, I don't want you to fill it up all the way, maybe about 80%. You see those little circles towards the top?
About here?
Yep, do it to just the top of those circles right there, Jane.
And is there a certain temperature that the water should be?
It should be about room temperature, because as it gets warmer outside and colder outside, you're going to watch that water go up and down in your thermometer. So Jade's going to pour this in. She'll show you how high you need to get the water into your bottle to make your thermometer accurately work. So you don't have to put it into a pitcher like we've done here. You can just take it straight over to the kitchen sink and fill it up from the kitchen sink. But since we don't have a kitchen sink here on the science desk, we got to get ourselves one of those, Jade.
Yeah, we do.
A little sink up here.
I can't talk and pour this water at the same time. This takes a lot of concentration. This is science in itself right here.
It is science.
Everyone sees my serious face.
Do you stick your tongue out when you do stuff when you're very concentrated? I always stick
I don't
my
know
tongue
what
out.
I'm doing with my face right now. I'm terrified to spill.
Great. You look great. So we're going to pour this water until it's about 80% full. You do want to have some air in the top of your bottle, so make sure that you don't fill it too full or it won't work. So again, you'll see as Jade's finishing this up here, she's going to go almost to the top, but not quite.
This is a giant bottle.
It is a giant. That's 2 liters. That's 2 liters worth of water that we're putting in there.
Okay.
Okay, we're getting close. Keep going, keep going.
Oh,
we had our first spill of the morning. It's not a good science experiment until somebody spills. A little bit more. Just a tiny bit more. Yeah, that's about right. Okay, so show everybody at home. Yep, that's about how full you want it to be.
See right about there.
Yep, you want to have that air at the top. Okay, the next thing we're going to do is let's get our index card ready. Oh, which we spilled a little bit of water on.
Kind of wet.
That's okay. That's okay. I don't know if we'll be able to write on it, but what I wanted you to do, we'll try, is we're going to draw some lines on it, because this is how we're going to measure the temperature. So just do a few horizontal lines across the card, and we'll see if it works when it's wet. It might not, but just keep your index card away from your water bottle for a little bit, and then, is it working?
It's working. It's
good.
working.
Okay. All is well. All is well in the science desk. Okay, perfect.
How many lines do you want?
That's great.
Okay.
That's great. Just somewhere in there. Okay, so hold it up. Show everybody what you've done.
Peel it off the table.
Peel it off the table. Okay, so she's just drawn a few lines on there like that. Okay, now set that aside, far away from the water. We'll let that dry out a little bit. Okay, now what we're going to do next is we need to put some of that red food coloring in so that we make it look like a thermometer. Because
right into here?
Yep, right into there. Now, obviously, a real thermometer would use mercury, and we're not going to do that. Mercury is very dangerous and very hard to get a hold of as well. So we're going to use colored water here. So we'll just keep dropping a few drops in there. Yeah, just throw a bunch in. Hey, more red food coloring, the better. So we're just going to let that settle for a second. It'll settle in and make that whole thing red, and so it will look like the base of a thermometer. Next step that we're going to do is we're going to stick our straw in, but don't just drop it in or it'll drop down to the bottom, and we don't want that to happen. We want about a half of our straw to be sticking out. So, yep, stick it in about, go up a little bit more, because we're going to hook this index card to the top of it. So you want to have enough room for the index card to be taped to it. Now we're going to take our Play-Doh. Oh, I probably should have had you open. Throw me the Play-Doh and I'll open it for you. Kind of hard to hold the straw.
Well, here. There we go.
Oh, just,
I'll take it out.
Good idea. Okay, good idea. Take the Play-Doh out.
I was going to use my teeth, but teeth are not tools.
That's true. That is absolutely true.
Play-Doh out.
Yep, Play-Doh's out. We're going to hold the straw in place with the Play-Doh. And this is the most important part, is when you put the Play-Doh on. So stick your straw back in like you had it before.
Okay.
Yep, about right there.
Okay.
Now push, just sort of mold the Play-Doh around the straw. Once you get it molded around the straw, you're going to want to push the Play-Doh down into the top of the bottle. And this is going to create a seal on the top of the bottle. So just press it down in there with your yep, you got it.
Okay.
You got it. And I think, yep, we're looking good, because can you see that little bit of
pink
in the straw?
Yeah.
You can see it coming up already. Okay, what we're going to do at this point is we're going to tape this card on. Now you'll notice that we don't have any numbers on this card. We don't have any temperatures on this card yet. And that's where you're going to have to be a scientist and be able to figure out what the temperature is and mark it on your card. So for example, inside your house, it's probably 72 degrees. So after you let this sit for a little bit, you're going to go and mark how far up the straw that red water has come, and mark that as 72 degrees.
Do I just tape it on like this?
Well,
or like this?
Let me show you.
Okay.
Let's do it at the top and bottom. How about? So let's go like this. Stick that at the bottom. So you'll want it to show everybody at home that.
Okay. Tape here, and then at the bottom.
So turn it vertically. Yep, like that.
Okay.
And let's actually, as I change it right now, put the tape. Same place, but move it to the opposite side so that your card can go behind the straw. Oh. Does that make sense? And that way you can see how high up the red water is, and then mark your temperature.
So like this?
Yeah, let's do it like that. That's perfect, okay? We'll just try to get it to stay like that. Now we've made our at-home thermometer. What I'm going to do now, and you can do this if you want, what's fun to do is when it's the summertime, you can take this outside and see that water rise through the straw, and you can mark it at 90 degrees or however hot it is. You just take a real thermometer and say, okay, this real thermometer says it's 90 degrees, and my water has come up this high, so that must be 90 degrees. Since it's obviously very cold outside, I mean, it snowed this morning, we can't do that. So what I did is I brought in a blow dryer, and you can do this at home too if you want to watch it go up and down. What I'm going to have Miss Jade do with the blow dryer, and it will get a little bit loud, is that we're going to heat up the water, sort of mimicking the sun heating up the water inside our bottle, and you'll be able to watch that red water come up the straw. Okay, so go ahead, Miss Jade.
Science magic.
Science magic. Just hold it right up there. Hold it closer to the bottle so we really warm it up. And it'll take a couple of minutes, but you'll be able to see that red water come up. Maybe do it a little bit lower on the bottle so that we, right there where the straw is. And I'm going to, while she's doing that, I'm going to check our seal. I'm going to push down our Play-Doh and make sure that it's sealed good enough. Because you've got to make sure that it's totally sealed in order for it to work right. I'm not seeing it come up, Miss Jade.
I'm not either yet. But our water was a little warmer, and I'm wondering if it's just taking a little extra minute for it to get even warmer.
Possibly. When your water is warmer than room temperature, it usually happens faster.
Oh, so I'm seeing it move a little bit.
I'm kind of surprised it's not warming up. Yeah, I'm not seeing it come up. Jade, why don't I have you turn that off for a second?
Okay.
I'm going to check our seal on this one more time and make sure that our seal is good enough. Let's see what we can do here. I'm just going to take the Play-Doh off altogether. Let's take our straw out too. We're going to get this to work.
Oh, yes, we are.
Okay, so I'm going to try to pull as much of this out as I can. It gets kind of messy if you have to redo it. I'm not 6 feet away from you right now. We're breaking the rules.
I know, but for science.
But for science, it's worth it.
That's what we got to do.
Okay, so let me try this again. Where did I put our straw?
Here we go.
Thank you. Okay, stick it in there. You hold it up for me, Jade.
Okay.
And then we're going to wrap this around, and you really want to push it down into that bottle. We might have our first science fail if this won't work. It's worked so good for me in the past. Okay, so
this is normally what happens to me when I try anything on Pinterest.
It's true.
100%.
It's true. Your moms have Pinterest fails. We have science fails. Okay, let's try heating that up again. We've really packed that Play-Doh in good there.
You see it?
Oh, there it goes. Oh, there it goes. Oh, what? Stop, stop, stop. We're going to overflow it. Science. So see, that's why it's so important to make sure that that seal is tight and packed in there well. Because if it's not totally sealed, then it's not going to work right. But do you see how it came up and down?
That was really cool.
Yeah, let's just see. There it goes again. Going up, 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 up. So that is how a thermometer works. We're going to overflow it again. Oh, nope, it stopped.
I learned my lesson the first time.
So isn't that cool?
That is so
As
neat.
the molecules in the water get warmed up by the sun or by a blow dryer, they start expanding and moving faster, and that causes the water to expand and move up the straw as long as your seal is totally good.
I think with my spillage, I got a little moisture in my seal.
Maybe. I don't know, maybe. But
and you're also actually just better at science than I am, and so that could have everything to do with it.
But that shows you that if you get an experiment that doesn't work for you, just start over.
Yeah.
Right? There's no mistakes in science because you always learn from your mistakes every single time. So you can just pull it back out and start all over again.
That was fun.
That was our fun little science experiment for the day, explaining how thermometers work.
I mean, that's great.
Yeah. So if you've got any questions for me, we've got a few minutes left. You can jump onto our Facebook Live, leave a question in the comment. Also tell me your name and maybe what school you go to, and Miss Jade's going to pull them up, and I'm going to answer a few questions now.
So we are starting to get a couple on our Facebook Live, and one of them is coming from 7-year-old Charlie.
Okay.
Charlie wants to know what determines hail versus snow.
Oh, okay. Well, there's a bunch of different types of precipitation you can get. Rain, snow, hail, and sleet. And there's several others too, but those are the 4 main ones. So hail is ice balls, okay? And snow is actually crystals, snow crystals or ice crystals. So it all has to do with the crystallization of it, whether it's a packed ball of ice, that's a hailstone, or whether it's a crystal, which makes a snowflake and doesn't do as much damage generally, right?
Isn't
as a
that
hailstone.
the truth? As a hail, right?
Yeah.
Okay. What about getting a question from Josh?
Okay.
Josh wants to know how a hurricane is made.
Oh, a hurricane is made from hot water or very warm water. The places that see hurricanes are generally places that have what are called warm ocean currents. So in the ocean, we have areas sort of like rivers through the ocean, if that makes sense. Some of them that are warm and some of them that are cold. Now off the California coastline, if any of you have ever been to the beach in California and you go run into the waves, you know how cold that water is. Even in the middle of summer, it's cold. Well, if you go to the beach in Florida, if any of you have been there, you'll run into the waves and notice that the water is much warmer. And that all has to do with the ocean currents. So for places that get hurricanes, they're generally in warm ocean currents. And that warm water is lifted and evaporates into the atmosphere. Remember how we talked about evaporation last time at science school? Well, you get a lot of that warm water just feeding into the atmosphere, and it creates a low pressure system. We're going to talk more about pressure next time on Tuesday, but that's what causes that hurricane. They're fed by that warm water off the coast of Florida.
Science is so fascinating to me.
Yes.
It really is.
Yes.
Someone actually just wants to know where you first learned about this experiment and maybe who taught it to you to start with.
I actually learned it from the internet. I learned it many years ago from
Just
the
as
internet.
fascinating
That's
as
right.
science,
That's
isn't
right.
it?
I go and speak to schools sometimes. They always like to do fun experiments like this. So I've, over the years, come up with these fun experiments. And so if you want to do fun experiments like this at home, something beyond what I've done here, you can go to YouTube and see a lot of people doing fun science experiments, or Google, and go, of course, with your parents' permission, and they should be there with you. But yeah, do that, and you can find lots of cool science experiments. And of course, every Tuesday and Thursday, we're going to be here doing cool science experiments like this to give you some ideas of things you can do at home.
And then also, Roslyn, 6 years old from Far West Elementary.
Okay.
They want to know if this will work in a smaller bottle. If you could use a
Probably
smaller
would.
bottle.
Yeah, just make sure that you leave that space for some air at the top. You want to
Space, yeah.
have about 80% of it liquid, 20% water.
Okay.
And you'll probably want a smaller opening like this so that you can get that
And make
seal
sure
in
that
there really good.
seal's really
It would be
tight.
hard to do this with like a cup because the top of a cup's much bigger, you know, and so it'd be hard to get a perfect seal like we can get with this.
That makes sense.
Yeah.
All right. So many great questions.
Yeah, lots of great questions.
Let's see, what else do we have? Oh, someone wants to know, 8-year-old Elliot,
Okay.
how long does a tornado last?
Oh, well, that depends on the tornado. Some tornadoes can last for a very short amount of time, just seconds or minutes, and then other tornadoes can last for hours. I don't know if you heard about the tornado that went through the Nashville area just a few weeks ago, but that tornado was on the ground for close to an hour is what the scientists there in Nashville are thinking. So they can last for quite a while, and then others will just last for a few minutes. So it really just depends on the tornado.
7-year-old Bryce from Bloomington Elementary wants to know, why is St. George hotter than the rest of the state?
Oh, that is a great question. St. George is so much warmer than the rest of the state because they're lower in elevation. If you've ever hiked a mountain, is it warmer at the bottom of the mountain when you start your hike or warmer at the top of the mountain? I bet it was usually warmer at the bottom of the mountain, and then it got cooler as you got higher. Well, guess what? Most of Utah is pretty high. We're at about 4,500 feet. That's almost a mile above the ocean, if you believe it or not. That's how far up we live, almost a mile. But St. George isn't nearly that high. If you drive down to St. George, you're going from Cedar City to St. George, you'll actually go down, 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 a long hill. You're dropping 2,000 feet in elevation about. St. George is much lower, and areas that are lower in elevation are warmer generally. So
do we have time for some more questions?
I think we do. We got about 3 more minutes, I think.
All right, so this is pretty relevant for us right now.
Okay.
Here in the Salt Lake, Utah area. Brittany, 8 years old from Odyssey Elementary, wants to know, why we can't yet predict earthquakes.
Oh, well, because we just don't understand enough about those tectonic plates and when exactly they're going to move. With the weather, we can predict that with certainty, or fairly obvious certainty, because we can see those storms coming, and so we can predict what direction they're going to move, but we can't see those tectonic plates and when they're going to shift. That's what gives you an earthquake, is when those tectonic plates underneath the surface of the earth shift, or they shift like this, they run into each other. There's different earthquakes that can happen, and we just cannot predict exactly when those tectonic plates are going to shift, just like that.
All right.
Hopefully someday we can.
Hopefully.
Wouldn't that be great?
I know, that would be fantastic. 7-year-old Blythe wants to know what makes a tsunami.
Oh, a tsunami is created when you have an earthquake under the ocean. And we were talking about those tectonic plates and how they shift. Well, sometimes if they shift, and they can shift like this too, that can push the water up and create a big wave. And then if that wave reaches the shore, that's when you get a tsunami.
So here's a good one.
Okay.
This comes from 9-year-old Kai.
Okay.
Kai wants to know, will a swimming pool get deeper if it's very hot outside versus if it's colder?
Oh, well, it will, not by a whole lot. Your water will come up a little bit, probably not enough for you to notice, but your water will expand, just like the water expanded here. It will expand a little bit if you were to compare a swimming pool in the summer and in the winter.
All these brains.
I know,
these
they're so
smart little
aren't they?
brains.
They are
I know,
so
it's
smart.
just fascinating. 7-year-old Lily wants to know, why do volcanoes erupt?
Oh, okay. Well, this all has to do with what's going on underneath the surface of the earth. We were talking about those tectonic plates and how they shift. Sometimes, we were talking about them shifting like this or shifting like this. They can actually pull apart from each other sometimes too. And that allows magma from the center of the earth to come up, and then it sometimes can explode out of a volcano if you get enough of that magma building up underneath the Earth's surface.
And that's a fun
Isn't
science
it so
experiment
cool?
to do as
Yeah,
well.
that's true. That is a fun science experiment to do. And we might have to do a volcano one at some point. That would be
I'll
fun.
volunteer.
Perfect.
I'll volunteer to help.
Perfect.
Yeah.
You'll be the messy one.
Yeah.
Just
It's
plaster
fine.
you.
Yeah, that would be great. Someone wanted to know if you have to use red food coloring.
No, you can use any food coloring. The only reason that we used red was to make it look like an actual thermometer, since they are usually red when you look at them. So there you go.
And Ruby wants to know why, or where rather, hurricanes are most common.
Okay, so they're most common. They usually form just north of the equator in the Atlantic Ocean. You can also get some in the Pacific Ocean as well that can go hit the Philippines and places like that. But for us in the Western Hemisphere, it's generally in the Atlantic Ocean, and then they follow that warm ocean current that I mentioned, because remember, they love that warm water. They follow it up, and that's why the east coast of the United States and the Caribbean and Mexico, the east side of Mexico, can get those hurricanes. So
I learned so much.
So many fun
in
things
Lindsay's
that we can
science
talk
school.
about, right?
And a couple people did ask, if you happen to hop on late,
Yes.
can they start this from the beginning? Can they watch your lessons
sure
over and over
can,
again?
Yes. So this will be posted to the Facebook page right after the live feed ends. It might take a second for the whole thing to load onto Facebook. But if you give it a few minutes, you can go back to our Facebook page, watch it there. You can also go to KUTV.com. We'll post it there. And 2 News has a YouTube channel as well, KUTV 2 News. So you can go to YouTube and watch previous episodes of Lindsay's Science School. Okay, so Tuesday's our next episode.
Yes.
9:30, don't be tardy. I give tardies just like your teacher does. We're gonna be learning about pressure. So I will post on my Facebook page, my personal Facebook page, we will post the materials that you'll need for our 2 experiments that we're going to do on Tuesday morning dealing with air pressure, high pressure and low pressure, and what that means for the weather.
Well, it makes
should
such
be
a big
fun.
difference.
It does make a big difference. It does. And you think about air as being so light and flowy, but it's putting pressure on you all the time. So we're going to talk about that on Tuesday's episode of Lindsay's Science School. Again, I'll post that list of materials that you need on my Facebook page so that you can gather them up over the weekend, and then we'll see you in class on Tuesday at 9:30. Thanks for being with us.